Video for Unit 5, Lesson 2, Dividing and Rationalizing Radicals. So in this unit or section, we're going to be looking at applying the quotient property to divide radicals and also rationalizing the denominator when needed. So the two properties we're going to see here are ones that we learned back in Math 2. The first is the quotient property. So this says that if I take the square root of a fraction and an a and b are real numbers, that it's the same as taking the square root of the top and the bottom, or the numerator and the denominator. So for example, if I'm taking the square root of 6/25, that's the same as taking the square root of 6 over the square root of 25, which would give you radical 6 over 25, or over 5. For rationalizing, that's when after we simplify, when we have a radical in the denominator. So just remember, if you do have a radical in the denominator, that's where we have to multiply the top and the bottom by whatever radical is in the denominator. So in this first example, I would multiply top and bottom by radical 5. We would get 6 radical 5 over radical 25, which is the same as just 6 root 5 over 5. And that would be my final answer. Same thing if I had a radical over a radical. I'd have to rationalize and get radical 30 over radical 25, which is radical 30 over 5. So those are two skills that we remember from Math 2. What we're going to start to see is when we have to use those properties for square roots, but also for cube roots, right, which we started learning about. So the first thing we want to do is when we simplify, if we're able to reduce the fraction, we always want to make sure we do that first. You can still get the correct answer if you don't reduce first, but it makes the problem easier to do. So I can see that 30 and 3 actually reduces to be 10 over 1, or 10 in the numerator. I have an x3 and then a y2. And now this is the same as doing the square root of 10x3 over the square root of y squared. So when we go ahead and simplify, the bottom, the square root of y squared is y. On the top, I have an x cubed, and there's again an imaginary index of 2 there. So I can pull out one pair of x's, and I'll have a remainder of 10x. And then this is as far as we go with that. So again, we're doing a square root for that one. I can't simplify root 10, and that would be my final answer. Next example, we're going to simplify the cube root of 48x3 over 3y9. So the first thing is when we look at this cube root, we can simplify what's underneath there. So 48 and 3 can simplify to be 16 over 1. And then now we're going to take the cube root of the top and the cube root of the bottom. All right, so now when we go ahead and simplify this out, when we take the cube root of 16x to the third, and we go ahead and simplify that, that 16 can be broken up into the cube root of 8 and the cube root of 3, or 2. And then I also have x to the third. That's, again, I'm just dividing it out, so one x gets to come out. So the top part of this actually ends up being 2x cube root of 2. The bottom part, I'm going to go ahead and simplify this out. So again, it's like just dividing the exponent by the index. So 9 divided by 3, I can get 3 groups out of that. And that's as far as we can go. So we would get our answer to be 2x cube root of 2 over y cubed. For the last example, this one is one where we might have to do a little bit of rationalizing. So 2/5 I can't reduce. It's the same as taking the cube root of the top, the cube root of the bottom, and we are not allowed to have any radicals in the bottom. So when we're rationalizing with the cube root, it's really like saying that we're trying to make this to be a a 5 to the third, right? So when I do the cube root of 5 cubed, I know I'm just going to get 5, right? So we rationalize so we can get rid of our radical. So if I have 5 to the first, I'm going to multiply it. It's almost like you're doing it 3 times, but we actually wouldn't want to really do it 3 times. This is really just the same as, and again, you wouldn't really write it 3 times. It's really the same as if I multiply the top and bottom by the cube root of 5 to the second, right? It's like I have to do 2 extra ones to finish that third. So now when we go ahead and multiply this out, I get the cube root of 5 to the third, which is 5. And then when I put all of this under the radical, I get 2 times 5 squared, which is the cube root of 50. And then there's no perfect square, or perfect cube, I should say, that goes into cube root of 50. And that's as far as we go. And that's it. If you have any questions, feel free to ask questions in class, sign up for T-Bolt time, or go to the center.